So today, like I said, this week, that is the remaining days, we're going to talk about fungible tokens. So basically, what is required of you to write a fungible token, the standards in this case, and we'll also be walking through a smart contract, a fungible token smart contract, sorry. So yeah, that is what we're going to cover in our remaining days. Okay. So yeah, today we're just going to talk about fungible token standards. Nothing really complicated, nothing really hard to grasp. Then like I said, you need to start working on your projects, your demo projects. That is, I know you already have all these tools in place. And today we're just going to go through fungible token standards documentation. And yeah, let's do this. So I'm just going to share this link in the chat again, nomicon.io. It contains almost everything you need to know about the NEAR protocol blockchain. Okay, so once you just click on that link, you should be able to see the page I'm sharing right now and many other things you can as well read related to the NEAR protocol blockchain. So maybe if I can just scroll on my sidebar, my left sidebar, there's NEAR protocol specification and some other terminologies, data structures and all that. So there's everything you can learn about the NEAR protocol blockchain over here, right? So one of these things that we're going to talk about today is standards. It comes last. You realize that. There's something you can as well learn about economics over here. So economics, if you're trying to economics of the NEAR protocol blockchain. Okay. Someone is unmuted. Okay. Yeah. So I was saying that we're going to look at standards, and under standards, there's a lot of things you can learn from there. So we have storage management standard. We have source metadata standard, token standards. We have, token standards. Under tokens, you have fungible token. We have multi-token and non-fungible token, okay? So we'll just be looking at fungible token. And under fungible token, we have the first standard we're going to talk about, NEP 141. And guys, just to reiterate, maybe if you're coming from Ethereum background or Ethereum blockchain, you must be familiar with ERC20 standard. ERC20 standard is basically the standard that is used by the Ethereum network to define their fungible token smart contracts. So there are some things you're needed to sort of implement or you're required to do within your smart contract for it to fully qualify as a fungible token smart contract. So these are what we refer to as the standards. There are non-fungible token standard. If I'm not wrong, I think it's ERC 721. I'm not so sure, but I think that is it. So let's talk about the NEAR protocol blockchain, and in this case, NEP 141 standard. So maybe if I can just read through the summary, it's a standard interface for fungible token that allows for a normal transfer as well as transfer and method call in a single transaction. And the storage standard addresses the needs and security of storage staking. The fungible token metadata standard provides the fields needed for ergonomics across dApps and marketplaces. So it uses an asynchronous sharded runtime. This means that the storage for different contracts and accounts can be located on different shards, and two contracts can be executed at the same time in different shards. So this is where we talked about callbacks. So if you're going to perform functions in other smart contracts, there's likely that those transactions or those transactions are going to take place in different shards. And so callbacks will help us achieve all that. And we're going to see actually how that can, how that is sort of used within a fungible token smart contract. So guys, you can just follow that link and read through all these theory right there for you to get a very good grasp of what is required of you to come up with a fungible smart contract. So I'll just go through this, the guide level explanation. And I really want us to be keen on this because there's a lot that will be needed of us to understand from that. Then we're going to go through the example scenario. We'll take, I want something you can understand easily. So, okay. So we can talk about the high level explanation over there and the assumptions and all that. Okay. So again, just before we go through this, fungible token smart contract, according to the standards that the NEAR protocol blockchain has laid, they are making use of storage management standard. These the page I've just opened. So these under storage management. So the storage management is basically storage staking, because in okay, let me just go give us a sneak preview of what a fungible token smart contract does. So a fungible token smart contract is basically transaction based. In this case, it's going to manage transaction of tokens from one account to the other, right? Now, these values or the information of the account holder, in this case, the wallet holder. If you have your Alan.testnet account and I have my own Paul.testnet account, and you're going to make some transactions within this particular smart contract, this information is going to be stored within the smart contract, right? And so in one or the other, we have to cater for the storage of that particular information on blockchain. Now, the way fungible, according to the standards, that is, the way fungible token smart contracts addresses that is they put this storage management in place. So the very first thing you're required to do before you can make any transaction within a fungible token smart contract, according to the standards, is that you have to pay for or stake some money, in this case, some NEAR tokens for storage purposes, right? So after staking the storage, then you can go ahead and do your transaction. And again, we'll be looking at that, or we'll be seeing how that is captured as we walk through fungible token smart contract in our coming session tomorrow. Yeah, so that is that. Let's just get back here and go through this. So let's go through this scenario. We should be able to do the following within a fungible token. Initialize the contract once. So the given total supply will be owned by the given account ID. So this is a pre-initialization of that particular smart contract. And maybe just to bring it to attention, after initializing a fungible token smart contract, if you're doing this for a production, then it shouldn't contain any access key to it. This way, it doesn't have censorship from anyone, okay? So it's going to operate independently. The code won't be changed once it's on a blockchain. So we should be able to get the total supply of the token, transfer token to a new user, transfer token from one user to another, transfer tokens to a contract, okay, given the wallet address, have the receiver contract call a method and return any fungible token not used. We're going to see again how that is used. Remove state from the key value pair corresponding with the user's account, withdrawing a nominal balance of NEAR that was used for storage. So if, let's say, I deregister from that platform, then whatever is staked for storage should be returned to me. And I think I talked about that in our previous sessions. A few concepts in scenarios above. We need to have the total balance. So actually, there's a function within the smart contract that should be able to help us find these. The balance owner. So this is basically the account ID that owns some amount of tokens within your smart contract or within the fungible token smart contract. Then the balance, the amount of tokens basically. We also need to have some transfer functionality within the smart contract. So this one basically moves tokens from one account to the other, either externally owned account or a contract account. So this is, the account could be owned by a person or the account could be a smart contract account, okay? Then we have the storage amount. This is basically the amount of storage used for account to be registered in the fungible token. Like I said, what you're going to stake for any storage purposes that are going to happen within the fungible token. Now there's some other explanation of the precision of the number of decimals supported and all that. Now your fungible token is going to hold some number of decimals. Like the near token has, like I said, 1 near token is equivalent to 1 times 10 power negative 24 yoked. Oh, sorry, 1 times 10 power 24. All right, okay, so that yoctonia, that is. So in other words, 1 followed by 24 zeros is equivalent to 1 near. So in this case, a near token has a decimal precision of 24 digits. I really hope someone got that and I never confused anyone. Okay. So that is basically what the decimal precision means. Again, we're going to look at this as we shall be going through a fungible token smart contract in our coming sessions. Now, the idea, maybe just before I proceed, the idea of fungible token is where we are having these other projects, the stable coin projects coming up. So a stable coin is basically a fungible token smart contract that follows all these guidelines, but with other, people call them complex, but if you understand it, you'll see the complexity is not that much, but definitely they are complex in a way. So they basically make use of fungible token standards to be able to achieve that. We've talked about, there are also some platforms, like I said, when you talk about the DAOs, decentralized autonomous organizations, when we need to upgrade the smart contract of that particular system, a DAO, then we need to have the stakeholders voting for that particular proposal. Now, whatever token that is used to do or that is put in place for them to be able to vote using is what we refer to as a governance token. So all these tokens, governance tokens, equity tokens, utility tokens, they are all types of fungible tokens. But then the smart contracts, if you go keenly into them, they follow the standard of a fungible token. So whatever you're talking about right here is enough to give you guys all you need to come up with all that, all solutions, fungible token solutions out there, okay? Now, there's a scenario right here. Alice wants to send 5 WBTC. So this is like wrapper BTC token to Bob. Then the wrapper BTC token contract is Alice. So the fungible token smart contract whose token in this case is referred to as WBTC is deployed to a wallet address of, sorry, to an account of this address. So that is what this statement means. Then Alice's account in that particular smart contract is called Alice, and the Bob's account is Bob. Okay. So again, this is just a scenario. The precision, that is the decimal of this particular token, is 10 to the power 8. So that is the maximum precision of the decimal. And the 5 token is, since this is the precision, if we are to calculate what 5 token would amount to or would accrue to, we take 5 by 10 power 8. And that would basically amount to what we can see over there, with quite a number of zeros after it. So in this case, Alice in this case needs to issue one transaction to these smart contracts, in this case, the FT smart contract, to transfer 5 tokens multiplied by the precision, okay, to Bob. So in this case, before these 5 tokens can be transferred, they have to be converted to the simplest, or the, I call it the atomic representation of that value within that FT, fungible token smart contract. Like in NIA, before you can send any NIA token, so if you wanted to send one NIA token, that value is first converted to Yocto NIA. Then after the conversion, that is when the transfer now happens, and the subtraction and addition happens within the smart contract. So if you're just to transfer it as it is, it would create or bring in some errors. And that's why we have the decimal precision. And again, we're going to see this when we talk about the fungible token metadata and how we can as well provide it within our smart contract. So we have some technical calls right here. So one, Alice calls this function on this smart contract, the WBTC smart contract. She's going to call this function, and this function is going to accept some parameters, in this case, receive ID and the amount, where receive ID is Bob and the amount being transacted or transferred is that. Now, token deposit to a contract. So a scenario is also given right here. Alice wants to deposit 1,000 DAI tokens. So again, we are calling the token name is DAI, to a compound interest contract to earn some extra token, okay? So the DAI token contract is deployed at this account ID or wallet address. And Alice account is Alice, and the compound interest smart contract is at this address as well. The precision is given, and the 1,000 token would be what is listed right here after the multiplication. So the compound contract can work with multiple token types. And again, you can look at further information on that, or how that is actually implemented. So a high-level explanation would be Alice needs to issue one transaction as opposed to 2 with a typical escrow workflow. Now, maybe just to contrast these with how Ethereum goes about it. And it's also one of the things that one of the things NIA has put in its architecture that makes transactions a bit robust than the Ethereum network. Now, in the Ethereum network, if you were to transfer some tokens from one wallet address to the other, then what would happen is the amount you wanted to transfer to the other address would be held in an escrow. And by holding in an escrow, I mean the value is specially stored within the smart contract. So the smart contract holds the custody of the value. Then if everything goes well, when the user you are transferring this amount to uses their wallet address to, it's like they're verifying the transaction. So that is when they can actually use that money, or the monies are transferred, credited to their wallet address. Now, with the NIA protocol blockchain, the escrow concept is removed. And so we don't need to, cater for the storage or extra storage, If you're escrowing something within the smart contract, it means you're going to accrue some tokens to cater for its storage, for the storage of that particular information. Now, with the concept of callbacks in the NIA protocol blockchain, that is eliminated. And so we can just, link all these transactions to the other. So if if it will fail at any given time, then everything is rolled back, because again, these transactions are atomic. So if a problem happens at any particular time, then the state is rolled back to its initial state. So right here we have the die. In the die contract, we are calling the transfer call function, and this is going to receive some parameters, the receiver ID. So in this case, the receiver ID is a wallet address of another smart contract. Okay, so we specify the amount that you want to transfer to that particular receiver ID or smart contract and a message. So behind the scenes, this function is basically going to invoke what we refer to as a cross-contract call. Okay, so it is going to invoke a cross-contract call to a smart contract deployed at this address, which is the receiver address, before it can fully make the transaction or establish the transaction. And again, you can read on all that. So during the call, this is how the DAI smart contract is going to process the transaction. So the very first thing it's going to do is make an asynchronous call to the compound smart contract. And in this case, the smart contract deployed at this address must, and again, note, must implement this method, FT on transfer. So FT on transfer, again, this is a standard, is required that the smart contract deployed at this address implement it, so that while this call is going to be made, the fungible token smart contract, in this case, the DAI smart contract, will invoke a cross-contract call to it. And what this method basically does, given the sender ID and the amount and the message, it will process the transaction further within its smart contract. So in this case, within the compound smart contract. And if everything goes well as expected, then it will return with a value indicating whether the transaction should succeed or not. Okay. So it attaches a callback. So if given the return value of this particular function after doing the cross-contract call, and again, if you can remember, while we were doing the cross-contract call, there was a way we were handling callback. Okay, so after the function we were calling using in a cross-contract call, response with some data, there's a way we were processing further that data. So that is the same thing that is happening right here. So this function is basically going to respond with some value, and we are going to invoke a callback function, in this case, FT resolve transfer function. And again, we're going to receive, we're going to pass the sender ID, the receiver ID, and the amount to this particular function for us to be able to process it further. Now, given the value returned by FT on transfer, we'll be able to know if we should transfer the tokens. Now that happens within this function, if we should transfer the token or abort transaction, okay? So the compound finishes investing using all attached fungible tokens given the function. So this is a function within the compound smart contract, then returns the value of the tokens that were used or needed, or that were not used or needed. Okay, so in this case, Alice asked for the tokens to be invested, so it will return 0. Okay, now again, what this statement really means is Alice transferred some tokens to compound smart contract with an aim to invest them. So if this method is going to return a value greater than 0, then it means the DAI smart contract will return that amount to Alice. Okay, so if it will respond with the 0, then it means that the compound smart contract used all the tokens that Alice sent. And so nothing will be credited back to Alice's address. And we're going to have our resolve transfer. Again, these are going to be a callback function that receives a success or failure of the promise. So if success, it will contain the unused tokens. So in this case, whatever tokens that were returned by this function. And the die contract uses simple arithmetic, not needed in this case, and updates the balance for Alice. Again, it will credit that to Alice's account. So that is basically what happens. And many other illustrations have been given over here. I'll not go through all these today, but you can read through. It's basically what I've been talking about. Let's skip to the reference level explanation. Now, this gives us an interface of the methods needed. So these are the core methods needed within your fungible token smart contract and an explanation against them, okay? So we need a method to be able to check the fungible tokens total supply, the fungible token balance given an account ID. So given an account ID, you're basically able to check their balance. Then you also need to do the transfer. So if you're sending some tokens from one address to the other, this is the function that that should be done from. Fungible token or FT transfer call. So if you're transferring some tokens to a smart contract, so in this case, the receiver is a smart contract. So this is the function we're going to use to be able to achieve that. FT on transfer, because I can say, I think I missed this. So FT transfer is where you're going to transfer tokens to a wallet address, in this case, owned by someone. FT transfer call is when we're transferring tokens to a smart contract. Again, the explanations have been given over here, guys, please read. Then FT on transfer, this is a method that will be required that the smart contract we are transferring tokens to implement, okay? And this is what is going to help us further process the method, sorry, the transaction, given the response of this method on that smart contract. Now from there, we have fungible token events. Again, if let's say something is going to happen within your smart contract, and like someone is trying to transfer tokens to a wallet or account ID that does not exist within the smart contract. In that case, the tokens are going to be banned. And by banning, it basically means the total supply is going to be reduced, okay? Minting means the total supply is going to be added, or other tokens are going to be minted. Now, this interface or this standard is basically going to help you listen for such events. So if, let's say, a token is banned, this will give you that opportunity of or a way to handle such events within your smart contract. Again, we're going to look at it as we walk through the code in our coming sessions. But maybe just to touch on this before we call it a session is the fungible token metadata. This is NEP 148. So I'll just read through the summary. So it's an interface for a fungible token's metadata. The goal is to keep the metadata future-proof as well as lightweight. And these will be important dApps needing additional information about the fungible tokens, properties, and broadly compatible with other token standards such as the NEAR Rainbow Bridge that can move tokens between chains, okay? So someone asked about if I wanted to transfer tokens from Ethereum to NEAR, how I can go about that. So this is what you can use to be able to achieve that. So let me just share the link with us in the chat. So you can basically read through this and see how you can design such an application. Okay. Apparently, you can make some transactions between me and Ethereum, as you can see over there. And I believe something is also, they're working on this to sort of extend it to other blockchains. So back to our metadata standard. So again, if let's say a smart contract or some other applications wanted to interface with your fungible token, then these metadata would help them handle operation or in this case, transactions to your smart contract. In this case, FT smart contract, way easier or way easier and better. So there are standards. There are standards that your fungible token smart contract is expected to implement. In this case, the metadata standards. So in metadata, let's go through this motivation first. Custom fungible tokens play a major role in decentralized applications today, and fungible tokens can contain custom properties to differentiate themselves from other tokens or contracts in the ecosystem. In NIA, many common properties can be stored. Sorry, guys, my internet is a bit unstable. Yeah, so these can be stored right on chain. Other properties are best stored off chain or in a decentralized storage platform in order to save on storage cost and allow rapid community experimentation. Let's just move on to the guided level explanation. So it allows for some discoverable properties, and some properties can be determined by other contracts on chain or returned in view calls. And others can only be determined by an oracle system to be used on chain or by a front end, the ability to access a linked reference. So a token provides metadata upon deploy and initialization. So in this case, if you're when you're going to deploy your fungible token smart contract, you have to provide all these information. So assume that Alice deploys the WBTC fungible token contract. The assumption is this contract is going to be deployed at this address, and Alice's account is this, and the precision decimal is also listed as well. So these are the assumptions you're going to make. And the high-level explanation states that Alice issues a transaction to deploy and initialize the fungible token smart contract, providing arguments to the initialization function that set the metadata field. Now we're just going to have a look at what a metadata looks like. So Alice deploys a contract and calls this function, the new function, that is basically to initialize the smart contract with all metadata. If this deploy and initialization were done using near CLI, then the command would be as follows. So in this case, you can ignore. I just want us to have a look at, or rather draw attention to what the information contained in the metadata. So this is just a command, near deploy to this account. The WASM file is that. The initialization function is new, and the function's argument starts right here. Now, within the argument in the JSON object, we have all that, whatever I've just selected. So all these data. Now, in the metadata, we expect you to give the owner of these. Sorry guys for that. Just a minute. Sorry guys for that inconvenience. So again, like I was saying, you need to specify the owner ID. So in this case, the address where you're going to deploy this particular smart contract. So that has just been given over there. Then the total supply. In this case, if your token is going to be capped in a way, it's going to have some market cap. So you can as well provide that information right here. So these are required for some other initialization within the smart contract. Again, I'll show you in code where this information is going to be used. And now to our metadata, we've been given some attributes that we can include, or what we have to, or what we must include within the metadata. But there are some other things you can include, which may not be appearing here, just to give some more, some more explanation about our token. So the first one is the specification, and this takes this value. Then we give the name. In this case, the full name of our fungible token. So it is a wrapped Bitcoin. Then we give the symbol. In this case, the symbol that our token will be using or will be represented with. So like for NIA, we have, for NIA token, we have N with a circle, right? N engraved in a circle, so something like that. So in this case, we have these as the symbol, WBTC, and then the icon. Then we have, icon is basically the image that is going to be used to, identify your token. So like NIA, we have this symbol looking like N. Then Bitcoin, we have some decorated B. Ethereum, yeah, we have another, we have one for Ethereum. So those are basically images that are going to represent our token. And it's advised that it be an SVG image if possible, because that will do the representation quite well, the appearance and all that. Then reference is basically a file that has been stored in an external blockchain storage solution of, external blockchain storage solution. In this case, it could be IPFS, it could be Web3 storage and all that. So this is basically a file that is going to give, represent these metadata information. Okay, so that if in any case anyone tampers with these metadata within the blockchain, then we can reference it with the other file that is stored in the external blockchain solution. And that file must, the file has to be time-stamped. And by that, I mean, we're going to generate a hash code or a hash string out of the data contained within that file, so that again, if the file is going to be corrupted in a way, we have something to check against. So in this case, we're going to know if the data is credible or not, or it was tampered with. So that again is what this is going to help us achieve. Then the decimals. So in this case, 10 power. So for this particular fungible token, its precision is going to be 10 power 8, because the decimal is 8. If let's say we gave 24 right here, then the precision would be 10 to power 24. So that is basically it. And this is how the command is signed. So he's basically signing this particular transaction. So this is all I wanted to show us in the metadata standard. So you need to provide this information to basically describe your fungible token. And again, we'll see why the information is needed while we do some practical, we interact with some practical smart contracts that we'll be working through tomorrow. Now, a fungible token contract implements the metadata standard shall contain a function named FT metadata. Why? Because if you wanted to, retrieve that data, then this is the function that will be expected to be called within your smart contract to provide that information. So that's why you really need to feature it within your smart contract. And it takes this interface. Okay, again, what I've just taken us through. So it takes this interface. You realize some are required, some are not required. So like spec, name, symbol, and decimal. Those are required. But icon, reference, and reference hash are optional, or they can't be null. Now, if you are going to provide a reference, then you must provide the reference hash. That is the catch. I really hope you got that. If you're going to provide a reference, in this case, an external file to describe an external file describing the metadata, then you must provide its hash. So that way we are able to validate the correctness of the data within that file. Yeah, so we've just talked about all this. And again, you can always read more. You can always read more on that. So I've just talked about all these guys. Yeah, so that is it about the fungible token smart contract. You have your smart contract must implement all these standards, or it has to adhere to all these standards for it to be compatible with the platforms, for it to be compatible with the marketplace, smart contracts, and the rest, for it to be able to be listed in the marketplace and all that. So that is it about the theory of smart contract, theory behind a smart contract, a fungible token smart contract. Sorry. So we have multi-token and non-fungible token smart contract, which you can read on your own. Unfortunately, we won't be covering these in this course, but you can always read that on your own. So in our coming session, we'll go through the code, a fungible token smart contract code, and walk through all we've talked about today. Now, the good thing with this is that NIA protocol blockchain has availed a module, okay? So there's a module, a standards module for this. Again, I really hope I can get this. So there's a standard module that is going to basically help us put all these in place without coding, without having to code the standards, okay? So let me just share these. I really hope I can get these running. So guys, if you have any question, by the way, you can just raise your hand. I'll give you some time to talk, or you can put it in the chat. I'll as well grant you the permission. So, okay. So, so let me just share this screen. Yeah, so these are the resources again. If you missed the link, and this will really come handy, guys, while you're going to submit your project. So please be sure you go through this. But that was not part of what I wanted to show us. So right here under developing in Rust, we have the NIA contract standard library. So there's a link that is provided right there. So this link or this page basically describes the code that has been already availed to us as developers for us to be able to write, to implement these standards within our contracts. In this case, the specific contracts you're working on, it could be a fungible token, it could be a non-fungible token, okay? So again, you can read through this. Just go to the resources, Sanctuary Academy resources, NIA Certified Developer. So we have the fungible token module. And the fungible token module is going to give us an interface of a fungible token, and also let me look at this straight. And also the functions we've just talked about, you see. So we are having the FT transfer, the fungible token transfer function right there. So these are going to be implemented within our smart contract. So we don't have to, again, if you're going to use this module or this library, you won't have to manually implement them within our smart contract. So we just avail them within our smart contract, and then all these will already be placed. Again, we'll be looking at them in detail tomorrow as we go through the code and how they're implemented in there, okay? So that is maybe what you can read on as you wait for tomorrow's session. So let me know if there's any question from anyone, what you think you've not got quite well, what you might have missed.